Contents of our projects: introduction, objectives, problem definition, hardware and software used, methodology, advantages and disadvantages, result and conclusion, future scopes and references. Introduction. The project deals with the detection and location of different types of cancer in an image data set using machine learning. We use supervised machine learning. In supervised machine learning, we are going to train the model for existing data set. It will be collecting image data set in machine learning. We will give in supervised machine learning, we will give data in advance. Basis of that data, the model will carry out inference on the unseen data. So the model will learn using seen data and try to calculate the inference or predict the output on unseen data. We are training the model using the transfer learning approach. Whenever we train specific machine learning model, we need a huge amount of data set. So collecting huge amount of data set and calculating it takes time and leads to some problem. So in transfer learning approach, it takes an existing model which already trained on some data set. We will modify that data so that it can predict. The pre-trained model is trained to detect different types of cancer using transfer learning method, using three different types of data sets, that is lung, bone and skin. The previous work studied showed in SVM approach for cancer detection. However, the previous work outlined detection of single type of cancer. In machine learning model, we train lakhs of images. We will take that model and tune the configuration of that features. We will feed our own custom data and make the model applicable for detecting the region of interest. We use model inference. We will be writing an Python code which should be interacting with the model. The Python program, it will feeding the images to the model. On the basis of that images inference, we will be done the model to predict the type of cancer. If the cancer is present in that image, it will show location and presentation of present of cancer. This project deals with the development of UI application, which is be fed with an image and detect and locate three types of cancers. We use GUI application, which is easy to use using TK inter model. It will select the image and show the output. If we are not using a GUI application, then the problem is we need to pass every thing using command line. So Python GUI application is developed for this. Next, objectives of. Next slide, Sunita. Objectives.
Continue, we're listening.
So objectives. First, objective of our project, the main objective is we are finding three types of cancer in a single application, capable of identifying and location of cancer in the image. The objective is to use transfer learning approach to train the model on a limited data set. To identify the skin cancer, considering and analyzing the features of cancer image, which will be including asymmetry, border irregularity, compact index, fractal dimension, edge abruptance, color variation and diameter. Identify the bone tumor by extracting the texture features such as angular second moment, correlation, entropy, homogeneity, contrast and dissimilarity. In identifying the lung cancer is a study of identifying the lung cancer in early stage and also predict the lung cancer so that survival rate of patient will be increased. to train the model till minimum loss so that it can predict the uh, output. In skin cancer, we are using asymmetry, which is the major axis of asymmetry, and calculate the degree of asymmetry in a tumor outline, border irregularity, change the size of the size and shape of the skin cancer growth, which may be blurred edge or rugged, or edges are irregular. Fractal dimension, it is provides a ratio of statistical index of complexity, comparing how detail in Python changes with the scale which it is to be measured. The color is not the same all over. It may be pink, white, or black brown. Uh, Evolving means changing in the size, shape, or color of skin cancers. Uh, Next slide. Uh, Problem definition. The problem definition, from the literature we have studied, we have come across multiple solution and study on detection of the cancer in image dataset. Most of these solutions are focused on SVM implementation. However, there is a few drawbacks of SVM, which are outlined below. SVM algorithm is not applicable for large data sets. SVM does not perform very well when the data set has more noise, that is, target classes are overlapping. In cases where no number of features from each data point exceeds the number of training model sample, the SVM will underperform. As a support vector classifier works by putting data points above and below the classifying hyperplane, there is no probabilistic explanation for the classification. Thus, we choose to use transfer learning machine framework to detect the different types of cancer in the image dataset using transfer learning approach. So next will be continued by Radhika Kamte.
Hardware used the system with the following specification: 8 GB of RAM, Core i5 processor, at least 5 GB of free disk. Operating system may be Windows, Mac, or Ubuntu. 1280 cross 800 of minimum screen resolution. Next slide. Software used: Python. Our entire project is programmed using Python. Python is an interpreted object-oriented programming language with dynamic semantics. It is a high-level built-in. It consists of high-level built-in data structures combined with dynamic typing and dynamic binding, which make it attractive for rapid application developments, as well as for use of scripting. And the next is ideal IDE. In this we have used Python 3 ideal programming. Ideally is integrated development environment. An IDE combines a program editor and a language environment as convenience to the programmer. Using IDE is not a requirement of using Python. There are many other IDEs that can be used to write program language, but IDE is the easiest way to write. Next slide. OpenCV. OpenCV is an open source computer vision library which is used for machine learning software library and machine learning software library. OpenCV was built to provide common infrastructure for vision applications and to accelerate the use of machine. perception in commercial products. Uh, Anaconda Navigator. Anaconda Navigator is a desktop graphical user interface included in the Anaconda distribution, which allows to launch a application and easily manage Conda packages environments and channels without using the command line. If you use command line, there will be a delay in output, or user may be not more comfortable with giving a command line. To navigate, get the navigator cheat sheet and install Anaconda. Uh, Anaconda Navigator is a desktop user included in Anaconda that allows to launch applications easily and manage Conda packages, environments, and channels without need to use command lines. Next will be continued by Sunita.
Coming to the methodology, the project consists of detection of different types of cancers using machine learning. As shown in the block diagram, we have developed Python application which will take X-ray images at input. Then pre-processing operations are performed on images using OpenCV, and the image is fed to the trained ML model which inference the presence as well as the location of the cancer in the images. If the cancer is detected, the type of cancer will be plotted on the image and the result image will be displayed in Python application. The methodology followed by the steps: gathering data, labeling data, generating TF records for training, configuring training, training model, exporting inference graph, and testing cancer detector. So here, first one is gathering data, in which, this is a primary steps for any supervised machine learning approach. Supervised machine learning means we are going to train some samples of data and those becomes trained data set. Later, we are going to feed test data to the network. If the difference between desired output and actual output is less, it's going to give us more accuracy. This is what the supervised machine learning. Before pre-processing, we need to collect data set for different types of cancers. To train a classifier, we need a lot of pictures or images which should differ a lot from each other. So they should have different backgrounds or random objects and so on. Image processing. So here the images, or we can say that data set, is collected larger in size. So this step involves scaling the images to be proper size to be fed into CNN and then using labeling tool to label the location of the cancer in the image. Then labeling data. It is also a part of image processing. It involves the labeling of the location of the different types of cancers in the images. Before the supervised machine learning, the data is split into two categories. One is trained data set and another one is test data set. So here, label image software is used for labeling the location of different types of cancers in the image. Later, which is used to generate the TF records to train the model. TF records means TensorFlow framework records. To generate the TF records, here with the images labeled, we need to create TF records that can be served as input data for training of the object detector. For that, all the images are converted into CSV format, which will then fed to the Python script to be made into TF records. So how to convert XML to CSV means, after image processing, we get the XML files for each image in the train and test folder. The XML images contain the class names and the location of the cancer in the images, which used for training of the ML model. The TF records are generated and then class names are modified in the TF records. Here we use three classes: skin cancer, bone tumor, and lung cancer, that we have clearly indicated in the codes. To generate TF records, we use separate script with input as the following parameters, like CSV file of label image, image directory, output. After generating TF records, we should get two files, one for train TF record and one for test TF record. Label map is a file which is used during inference of the train model. Inference means a conclusion reached on the basis of evidences. So in our case, we are using 3 class names for 3 cancers. The label map file will be saved with .pbdex extension. Then training configuration file. Since we are using supervised machine learning with transfer learning process, we will be using an existing model to train our cancer detection system. So here we are using MobileNet SST for better accuracy and speed. And we will use the existing configured file and modify it as per our needs. Then GUI application. The GUI app for the cancer detection system is developed in the OpenCV and TK Inter. The system will facilitate the easy loading of the image and immediate detection of the cancer if present. Next will be continued by Swati.
Next slide. Coming to the advantages. Machine learning can review a large number of data. In a machine learning, you need not do every step of the way. And the transfer learning algorithm gain experience. They keep improving in accuracy and efficiency. It will handle the multivariety data. The system can detect the cancer with a less negatives. The proposed method of implementation also has a less negative result and can be used to detect a multi types of in a single model. And it is faster compared to other approaches such as SVM, support vector machine. And next slide. And coming to the disadvantages, data acquisition. In a machine learning requires a massive data sets to train and test the model, and time will consist more. Machine learning needs enough time to let the algorithms learn, and the high error susceptibility required large data and inaccurate if the location of the cancer is non-significant. Next. And coming to the result and conclusion, here it will detects the location and the presence of the cancer. In the left side it is the original image or the input image. On the right side it will shows the presence of cancer and accurately predicted for output images. And this is, and for skin cancer we take the normal images. For bone cancer and the lung cancer we will take the X-ray images. And here, from this implementation of the project, we can conclude that the developed application can provide an easy way for detection of cancer in an image using machine learning. The images are just fed to the Python application, and the developed system will detect the type and the location of the cancer. This can provide an easy tool for the medical professions. It will use it for the medical purpose to detect the cancerous condition with the easy method. Next. And coming to the future scope, the project can be modified for accuracy by training on a huge data set in a machine learning. More the data, more the accuracy. How much the data will be given, it will shows the more accuracy. For future we can modify this software only, and it can handle the different number of cancers of a data. Next. And these are the references we had gone through.
Now I will show the demonstration of my project. So here I will show the demonstration of different types of cancer detection using machine learning. So here we have developed entire system using Python and machine learning. For machine learning, we have used transfer learning approach, which uses TensorFlow framework character base. So first Let's open the terminal. Once it opens, I will write command as Conda environment list. Conda environment list. It will take some 5 to 10 seconds to activate this. We need to wait for, yeah. Then we'll give command as Conda activate cancer detect for activating the environment. Enter. Then we'll navigate directory where we save the code. So I will go to this folder where we have trained all the images. I will copy this path and paste it on this. Enter. Then to run the program, I will give command as Python GUI app.py. GUI app means GUI app. Then we can see a small rectangular window on top left corner. Yeah. Then this is the application what we have developed to load the images from the cancer dataset. So I will click on this to select the image. So first I will show the output of skin cancer. So I will take any one of the image of skin. It will show the output now. Here we can see two images. On left side, what software we have developed, it will load the original image here. The skin cancer is there, but I don't know the location of that. Whereas on the right side, it will display the image where in rectangular, we can see a small rectangular box. It displays presence as well as the location of cancer. And here we can see 2.99 means there is a unique ID for each of the cancers, and this 0.99 means the image is confident of 99%, means it is giving 99% accuracy. Then I will select the image for bone tumor. For bone tumor, we have almost 300 images over here, in which I will select any one of the image. Then we will get output like this. Again, we can see two images on output window. So here on the left side, what software we have developed, it will load the original image where we don't know the location of the tumor. Whereas on the right side, it displays the image where in rectangular box, it displays presence as well as the location of the cancer in that image. And here we getting like this. So this is the image of bone tumor, and bone tumor has been accurately predicted in this image with the confidence of 73% on right side, where we can see over here. Now I will show the output of lung cancer. For lung cancer, we have less number of images, only we have 50 to 60 images. It will show the output. Yeah. Again, we can see two images on output window. So here on the left side we have developed what software we have developed. It will load the original image, means input image, in which we don't know where the location of the cancer is. Again, on the right side in a small rectangular box, it displays presence as well as the location of the cancer. Again, in this Anaconda prompt, we are getting like this 3.54 lung cancer, means this is the image of lung cancer, whereas The lung cancer has been accurately predicted in this image with the confidence of 54% on right side where we can see image. So this is this completes the demonstration of my project.
Sunita,
Yes.
please use different, X-ray for the bone cancer, because whatever that bone cancer diagram using the PPT and this one is almost same. I would
Okay.
like to know the one more image for the bone cancer. Please do
Bone
it.
cancer. Okay, sir.
Yeah.
Here I will select image. I will take this image, second one. Yes, sir. We are getting output like this.
Different one. Please take a different one image. Sunita.
Okay, sir.
Yeah.
Yes, sir. It's giving 99%, sir, accuracy.
Okay.
Can I stop?
Now everybody. Okay, fine, no problem. Everybody, you can unmute your microphones and you can give me the answers. What is machine learning? Anyone? What is machine learning? Radhika, please unmute your microphone.
Hello, sir.
What is machine learning?
So, machine learning is a facilitate the computer to program themselves. Sir.
It's not clear. Radhika, Sunita, Swati. Yeah.
Sir, I will. Machine learning
Okay.
is it is composed of algorithms that educate computers to carry out tasks that are performed naturally by humans on daily basis. Uh, and as compared to traditional programming, it is characterized by automating the process of automation. Data and program are provided as input to the computer to produce output. Whereas machine learning, here we are giving the input as a data and output, and it itself create program.
What is the essential of CV here? You are using something CV now?
OpenSea.
Open.
No, OpenCV. OpenCV. Why OpenCV is required in this programming? Can you elaborate, anyone?
Yes, sir. It was built to provide a common infrastructure for computer vision applications, sir, to accelerate the use of machine perception in the commercial products.
Okay.
We used Python language now, sir. Again, in which
Huh.
we used OpenCV.
OpenCV. Okay. So you're from Anaconda, isn't it?
Yes, sir. Anaconda.
Okay. So how many images are used for tumor, bone tumor,
Sir,
and lung cancer?
And OpenCV is
Sir.
used to perform
Sunita, your voice is not clear.
No, sir. Radhika explaining. Radhika saying, sir.
Okay. Radhika, go ahead.
Sir, wait,
Sir,
I
I'm
will tell.
not able to hear, sir. Sir, question.
See, Sunita, if you give only answer, then only get more marks and other will lose the marks. That's all. Sushmita is totally silent, Swati is totally silent, Radhika is totally silent. That means you
So,
are going to lose the marks.
so OpenCV is a cross-platform library, sir, which will develop real-time computer applications, sir. It mainly focused on images, sir.
Hmm.
So OpenCV is in our project mainly used for image processing and for
Okay.
the development of GUI application.
Okay. In Anaconda, which Python version is using that?
3.7.
3.7, sir.
3.3.7.
3.7.
Okay. What about the IDE? IDE.
Sir, integrated development environment, sir.
Huh. What is the use
It is
of that?
written completely in Python, sir. The Python Spider IDE is written completely in Python. It is also known as the scientific Python development, sir, because it is designed by the scientists and is exclusively for data analysts and engineers.
Huh. See, in the moment when you open the Anaconda, we can see that various, the some sub softwares are available in that, like
Yes, sir.
Jupyter
Jupyter.
and Spider is there, and
Spider.
R something is there. So why would
Yes,
you
sir.
prefer Spider instead of Jupyter now? Because the beginner usually prefer, Jupyter is the more Jupyter notebook, more easier than this one, isn't it? Why you prefer Spider in that?
We are you beginners.
Just a minute. Here we lost the power. Just a minute.
Okay, sir.
Power loss of the ಅಂತಂದ್ರೆ we can make use of this headphone and camera on ಇಡೋಣ. Hello. Am I audible to
Hello,
everyone?
sir.
Yes, sir.
Yes, sir.
Okay, okay. I made some alternative arrangement right now. Just a
Sir,
minute.
why it is not audible?
This is not audible right now. Hello.
Yes,
Audible,
yes,
sir.
sir.
Yes, sir.
Audible, sir.
Audible, sir.
Now it's audible.
Okay. Now tell me what are the special features of Spider in this one? Hello.
So Spider is the open cross-platform integrated development environment. Um,
Okay.
So it has some of remarkable features like customizable syntax highlighting, sir, and it has availability of breakpoints, sir, and it can clear variables automatically,
Okay.
and it provides real-time code introspection. So that's
Okay. Okay. Okay.
Sir, earlier you asked one question, sir. How many images we have trained like that? So for
Yes.
bone tumor, we have trained 300 images, sir. And for skin cancer, we got only 80 images. Whereas lung cancer, we got means very less images, like 50 to 60 images.
Okay, okay. Okay, you may leave the meeting now. Your demonstration is over. You may leave the meeting now. Okay.
Okay,
Thank you,
sir.
sir.
Okay,
Thank you.
Thank you, sir.
thank you, sir.
Okay. Okay. Okay.